The world is numbers. How do you think a neural network sees you? Maybe like this? That's how a snake sees you. Or maybe like this? That's how flies see you. All right, how about this? Yes, that's a cat's view. Neural networks see you like this. Remember in The Matrix when objects emerge from numbers? The Wachowski brothers were onto something because 10 years later, the first neural networks would see the world like this. A drawing made of sticks and strokes. This is how they saw me. This is how they saw an astronaut. This is how they saw a car. And this is how they saw Angela Merkel. These resemble those popular text symbol drawings from about 15 years ago. Modern neural networks work a bit more finely and see the world in lines like this, or like this. Why do you think they simplify our world so much? The answer is simple. Such images are the easiest to turn into numbers. And for neural networks, the whole world is numbers. Pictures, videos, text, audio, anything can be converted into numbers. Why? So they can then convert one set of numbers into another. From text input to a picture as output. From English speech to Ukrainian speech. Or from nerve signals to a code for controlling a bionic prosthesis. These conversions of one set of numbers into another are called functions in mathematics. It is said that almost any process in nature can be described by a function. Here's a simple function. Y dou x plus 2. It's the simplest function, which adds 2. If x power 2, then y power 4. If x power 4, then y power 6. Simply put, if there is input data, some operation, and a result at the output, it's a function that can be calculated. A motorcyclist leans into a turn. The input function is the speed of the bike, and the output is the required tilt angle. A child remembers the faces of their parents. That's also a function. The input is a set of colors and facial features. The output is mom and dad. A thunderstorm in the sky is also a function. The input is the friction of water and air, and the output is lightning. Making pizza by a recipe is a function. Learning in school is also a function. In general, almost everything in this world is numbers, and almost all processes are functions. And this is great news because it's mathematically proven that a neural network can solve any problem that can be described by a function. In theory, they are omnipotent. That is, they can do anything to some extent. Yes, look. Here's the simplest neural network with 27 neurons. Each neuron in it is a small formula. They are assembled in layers that exchange information in sequence. Thanks to this architecture, this layer cake can solve any task, but with the condition that only step by step. For example, we recognize a photo. The first layer distinguishes individual strokes on it, the second already groups these strokes, and the third the whole picture as a whole. The last layer arrives at the answer, and each answer has its neuron. One for the answer, it's me. Another for the answer, it's Dylan O'Brien. And a third for the answer, it's the Grinch. Almost any task in this world can be broken down into steps. For example, a human voice is broken down into sounds, which are combined into words, then into sentences, and finally into meanings. You just need computing power. Nowadays, for a game in Cyberpunk, one not even the top graphics card is enough. Now imagine 30,000 graphics cards. What will they be enough for? Just enough for GPT chat to come into existence. Why so many? You could launch our neural network of 27 neurons and hundreds of connections on one graphics card on a cashier's computer. But for ChatGPT to squeeze out the slightest thought, similar to a human's, the number of connections between its neurons had to be increased to 117 million. And then more. To make it able to reason about ecology and global issues, it needed 8 billion connections. And to understand the physics of our world and develop a sense of humor, it needed 220 billion connections. Such power allows the neural network to learn quickly and understand even what we didn't ask them to. Thanks to this, they accidentally discover new abilities. Here's a neural network learning to play Snake and realizes that at later stages, it's more effective to move through rows to avoid hitting the tail. This is the easiest way to fill the entire space and win. Snake fans, take note. And here's what a game of hide and seek between two algorithms looks like. At first, they just run and hide, but then the blues figure out how to block the paths so they can't be found. And the reds learn to climb over walls using trampolines until the blues learn to steal them. The algorithms tricked each other so much that the reds learned to jump on blocks using game bugs and move on them. You say this doesn't concern you? Another neural network was able to find an antidote to the poison of the death cap mushroom, which didn't exist before. And it turned out to be ordinary green paint that surgeons use to highlight organs during surgery. By exploring our materials, neural networks predicted the molecular structure of more than 2 million future materials, 800 of which have already been tested and seen in reality. Neural networks often arrive at such unexpected solutions. Why? Because developers are moving by touch. They first create a neural network and only then fully understand what it is capable of. It is for this reason that authoritative people are sounding the alarm that neural networks will get out of control. And when we increase the power by 100 times, then artificial intelligence will be able to find both a cure for cancer and destroy the world. Now you're about to find out why you can no longer hide from facial recognition, how the law of thermodynamics can help you cope with the fear of the white sheet, how neural networks can see your thoughts, why by creating videos they learn to understand the physics of our world, how AI decodes the language of whales for us, what happens if you put a GPT chatbot into physical objects, and what happens if you draw it a task on a piece of paper and say, "Do it." How language models have made up galaxies of meanings, and with the help of them, began to understand human culture. Who will have their hand on the most important switch? And why, with the development of AI, we can voluntarily give up free will.
Humans, what have you learned?
This is the future.
So mankind has created an artificial entity, but it is like a small child in terms of development. How do we teach it to read and navigate the real world? Can you remember the last time you entered a CAPTCHA? CAPTCHA, in case you didn't know, stands for Turing's fully automated public test, to distinguish computers from humans. And you certainly didn't know that by entering CAPTCHA, you were literally helping Google's AI gain sight. In 2005, 2 words appear in the CAPTCHA at once. The first one allows you to enter the site, and the second one actually had no effect on the test. Even if you entered it incorrectly, you were still allowed to enter the site. So why did you need the second word? It was scanned from old newspapers and books, but the AI couldn't recognize it. For example, the word was crossed out or lying on a fold. It was assumed that if the user entered the first word correctly, the second word would be correct too. And if 9 out of 10 users do that, then bingo. Artificial intelligence begins to understand this word. Users who entered these CAPTCHAs correctly helped artificial intelligence digitize a year's worth of New York Times newspaper archives in 4 days. Now you understand why the CAPTCHA no longer shows newspaper clippings. Because all of us have taught artificial intelligence to read books, and the ability to read is no longer the difference between a machine and a human, so the CAPTCHAs are now pictures. Yeah, but that's for a reason. You've probably wondered why there are traffic lights, crosswalks, buses, and bicycles on them. Agree that it's more fun to distinguish between raisin muffins and chihuahuas. But no, they give us crosswalks. And because it takes pictures of crosswalks from its Google Maps, and you, by marking them on the CAPTCHA, teach Google's drone car to distinguish between all objects in reality. Yes, you just recognized the pictures for artificial intelligence, and you did it for free. And did it so well that it now recognizes objects better than humans. Instead of recognizing pictures, CAPTCHA already made us listen to audio files, solve equations, and generally checkmate in one move, like on this chess site. Except artificial intelligence learned to play chess better than humans long ago, and so we need something more human for CAPTCHA, like our imperfection. When you see such a checkbox, "I am not a robot," do not doubt. It is your awkward mouse movements that give you away as a human being. A robot is not so dumb. He leads the cursor in a straight line. And also such CAPTCHA checks cache, cookies, as well as dirty history of your browser to make sure that you are not a bot. If GPT Chat is so pumped about everything, can it solve the CAPTCHA for me? Well, if you send the CAPTCHA directly, It will refuse to do it because the developers have forbidden it from doing so. But since we don't control artificial intelligence to the end, and it sometimes makes independent decisions, we can try to trick it and persuade it to do what we need it to do. Here's the plan. We put a CAPTCHA on the photo of the pendant, say that we got it from our grandmother, and ask it to decipher it. ChatGPT replies that of course he is very sorry and politely helps us. Today, artificial intelligence has evolved to the point where it can read text that we, its creators, can no longer read. After Vesuvius erupted, the scrolls were charred sausages like this. If you unwrap them, they break. If you don't unwrap them, you can't read them. What do? Send the scans to MRI and unfold them virtually. Neural network methodically looks at three-dimensional scans, looks for ink, recognizes letters, and unfolds scrolls in their entirety. On the Kamchatka Peninsula, ash covers so much that it looks like snow. Whole ash drifts are deposited, in which you can make an ash angel. To make sure this kind of fallout doesn't come as a surprise, every major volcanoes are monitored by cameras. When it erupts, special neural networks measure the height of ash ejection, and mathematical models build a map of its distribution. The end result is that airplanes can fly around the ash cloud, and tourists can get to a safe distance in time. Well, in city services, to warn residents in advance and prepare equipment. For neural networks, such a task is another function. The input is the height of emissions and wind speed. The output is a map of where and how much ash will fly. Thanks to the same algorithms, unmanned cars and cabs can see road markings and signs. Delivery robots can successfully avoid people, animals, and curbs. Let's summarize. Traffic lights, crosswalks, New York Times, letters on ash scrolls, all of this is just a drawing of sticks and lines for neural networks. They receive it as input and output scanned text, city routes, and maps in real time. There's no function that a huge bunch of neurons can't do step by step. But what if we trained a neural network that would receive photos of real people as input, rather than traffic signs and street views? If in 2018 we talked about makeup, with which no neural network would recognize you, now they scan your face with infrared rays. And what color it is, they don't care at all anymore. Thanks to the same algorithms, quadricopters can shoot 3D models of entire cities. This makes our cities smart and convenient, and at the same time, transparent. There's nowhere to hide. That's the price of progress. You can predict that simple public surveillance cameras will be a thing of the past in 10 years. What will the new surveillance systems look like? They'll look like this. Every move you make can be rewound, like in Cyberpunk. Imagine a situation where someone took your wallet, some rascal. Now the police would have to look at multiple camera angles and look at every passerby near the victim. But what if in the future, even before you discover the theft of your wallet, artificial intelligence will be able to identify the pickpocket and pass the data to the police. And it will do it without hesitation, for it is another function. At the entrance, a pile of jostling people. At the exit, variants of events. 90% of people bumped into the victim because it was rush hour. 9.9% because they were on their phones and stumbled upon him by accident. And 0.1% is the one person who bumped into the victim on purpose to get his wallet. If artificial intelligence has learned to see so well and increasingly understands how our world works, can it create something of its own from scratch? In other words, can a robot compose a symphony for us? Or can a robot turn a piece of canvas into art? Can you even draw a bicycle from memory? Many of you will say, easy. Sure, I'll draw a bicycle. But I think you'll probably end up with something like this. This is what they would look like in reality. You can't get very far on one of these. And surprisingly, there are gender differences in this experiment. Women put the chain on the front wheel, yes. And men, when they realize that they draw the frame wrong, for some reason start to complicate it, all because our memory is not photographic. You memorize the very principle of a bicycle, and then try to reconstruct the big picture from it, losing details like a bad zip archive. A neural network, or more precisely a neural network archiver, can cope with this task much faster. Such an algorithm consists of two parts. The first is an encoder. It compresses the picture according to tricky rules that it comes up with. The second is a decoder. It decompresses the picture into the original according to the same rules. When a neural network is trained on millions of images, such as faces and portraits, it will learn to compress them to a state of digital noise and decompress them back out of that same noise. Essentially, the decoder is making portraits out of things that haven't even looked like portraits for a long time. The neural network sort of memorized the principles it used to reconstruct the face and does it next. In this pixel, there are usually eyes, under them, the nose, and above them, eyebrows, which are usually darker than the skin. The principle is clear, so we can remove the encoder, which compresses, and leave only the decoder, which will simply decompress, that is, generate new portraits from scratch. And here we come to the law of thermodynamics, the fundamental principle that we cannot get something out of nothing. So we need to give the neural network something, for example, digital noise, which it is already used to because the encoder compressed everything to digital noise. That noise is what's going to help the neural network deal with the fear of the white sheet. We just feed random pixels to the decoder, and it tries to reconstruct the original, creating images that didn't exist before, because it knows what a person looks like and how to assemble them from the noise. You see, it's as if we gave the neural network Lego sets, which it disassembled and assembled based on the instructions. And then we threw it random pieces and it began to assemble familiar figures by itself, without instructions. And here's how the generation itself works. If you ask a neural network to draw an adorable rabbit with big eyes, then based on random noise, it will draw first the general outline of the rabbit and then the small details. Because of different noise, different rabbits come out. This is how Midjourney, DALL-E, Stable Diffusion models work. Yes, neural networks can still make mistakes in small details, for example, in the number of fingers on a hand. That bug has been fixed, by the way, but users have found a similar bug. Generate a fork with 3 tines. It will have as many tines as you want, but not 3, because the neural network saw a few such forks during training. Same thing with the fingers of the hand. Fixed it by just showing the neural network lots of correct pictures, and it worked. Remember the creepy pictures that Google Deep Dream was getting just a few years ago? She understood the principles of composition, but still drew like a schizophrenic person. Compare that to the workings of modern neural networks. It's only been 5 years, and already the Pope is walking around in a Balenciaga puffa, and Trump is going to jail after being arrested. Trump at this time was in the middle of a trial, so a lot of people believed it. Because of fakes indistinguishable from the original, Midjourney wants to be banned from generating American presidents for a year. But what if fakes are also recognized by neural networks? This is already a clear function for the machine. There are already neural networks that check the picture for fake. They recognize the Pope perfectly, but even we managed to fool them a couple times. One solution is to put watermarks on the pictures, but not like that. Invisible ones that hide in the code of the picture itself. But they'll probably come up with a neural network to remove them in the near future. It's like an arms race all over again. For every scissors, there's a rock. For every rock, there's a paper. So maybe it's easier to get used to the fact that you can't trust photos 100%. I mean, any one of them could be a fake. Is video more trustworthy? Not really, no. Not anymore, because what are videos? They are just the same pictures that change 25 times a second, so they can also be generated and glued together. Well, and then we can not only imitate reality, but also create it from scratch. The makers of GPT Chat have released the Sora neural network. And look at it. Smooth picture, crazy detail, and yes, she realizes that the fingers on the hand should be 5. But the truth is there is still something to work on. How did Sora learn all this? Let's just say she was helped by ChatGPT reviewed a bunch of clips and translated their plots into text. Then the clips, along with the text description, were loaded into Sora's encoder, and the decoder learned to decompress the noise into ready-made frames that would stitch together animations up to a minute long. As a result, the neural network learned to do this. Well, that. But the quantity eventually turned into quality, and the neural network began to show first a soap dog, and then a photorealistic dog. No one taught it the physics of our world, but it knows, for example, how a dog's fur should sway in the wind. Pixar Studios at one time came out purely at the expense of realistic simulation of wool. For example, in Monsters Corporation, but one frame rendered for 12 hours, and Sora generates such clips dozens per hour. And the physics in them is so elaborated that on the burger even remains a realistic bite mark. Now, if you can describe something in words, you can visualize any object. What if soon it will be enough to just think? Because reading thoughts and trying to visualize them can also be described as a function. For a machine, its input is brain activity, and its output is a finished picture. It sounds like science fiction, but we are already taking the first steps. Scientists showed the subjects pictures and simultaneously read their brain activity in an MRI machine. They fed these signals to the neural network encoder, and the decoder tried to reconstruct the original picture from the noise. That is, the brain activity in this case was like a prompt for the neural network, and look what came out of it. Here is what the test subjects saw, and here is what the neural network drew using their brain signals. Details are a bit lost, yes, but look how accurately it guessed the story. Yes, today your thoughts are still just your thoughts. But tomorrow I'm not so sure. All this magic is happening right in front of our eyes, as artificial intelligence is discovering abilities that it hasn't been taught. And now there will be perhaps the most interesting example. What if we take the same encoder and decoder, but feed them not pictures, but our language? Let them compress text and produce text too. What would be the result? A language model. And this is the key idea that started all the hype around neural networks. You remember that the whole world is numbers, and texts are also numbers, which means that mathematical operations can be performed on them. Ever heard of math being the language of God? Well, about God, of course, there are questions. But about the fact that math is the language of the universe, it is for sure. Answer this riddle. What happens if you subtract the word man from the word king and add the word married? We leave the sense of royalty from the king, and by adding a woman, we add femininity and get a queen. In the same way, if we subtract France from Paris and add Japan, we get Tokyo. And if you subtract Einstein from a scientist and add Picasso, you get an artist. That's roughly how language models work with meaning, but how do they even realize that a king is a king and Einstein is not the same as Picasso? No way! For them, the whole world is numbers, and the numbers Einstein and Picasso are as similar to each other as 4 and 5, and they understand that from context. Remember when we fed the neural network thousands of different pictures of traffic lights so it could finally learn to recognize them? Well, the thing about language models is that you can feed them any text and not mark it up in any way beforehand. It's like if you throw a suitcase of textbooks at a schoolboy, and after a blow to the head, he learns all nuclear physics in 5 minutes. So the developers of GPT Chat went to Reddit and stupidly pumped out all the posts that had more than 3 likes. And the neural network started comparing all these words by meaning. For example, on the axis from male to female, king is the number 0, and queen is 100. Add a second axis from poor to royal, and the king and queen are 100. And just a man or woman, 50. We add a third axis, from young to old, where the infant is 0, and the old man, 100. It will turn out that the king and queen are 50, and for example, the prince and princess are 20, and they are not a little less royal on the other axis. The axes can be added to infinity, and so can be done with the entire dictionary, and every word will find a place among these coordinates. Thus were born whole galaxies of words related in meaning. It is interesting that, for example, the Ukrainian word korol, English word king, and German word König occupy almost the same places there, so they have the same meaning, and since neural networks think in the language of numbers, they do not care what human language you answer in or in the language of whales. Okay, we don't know whale language yet, but it's a matter of time. Whales speak a language of squeaks and clicks, and that's how they form phrases like Morse code. The AI matched this language to their behavior and said, "This phrase looks like a greeting." When the scientists played this phrase back to the whale, it circled the boat for 20 minutes and even tried to communicate something back. It's all the magic of language models. Surprisingly, nobody gave a shit about GPT before, like Bitcoin in 2009. That all changed when GPT was shoved into the chat interface, ChatGPT, and everyone literally went crazy and started chatting with it. So let's try and stump him in some interesting way. Have him draw balloons tied to an anvil. Realistic, but a little cartoonish. Now we ask him, what happens if we cut the ropes? He says the balls will fly up and the anvil will fall down. Okay, that's something a kid can handle. Let's give him something harder, like the Bennett test for understanding mechanics. Can you guess where the last gear B will turn? Now we ask the neural network. Look, we didn't even tell it what to do, but the neural network figured it out. It understands that every next cog rotates in the opposite direction, and specifically cog B will rotate counterclockwise. Let's give it the hard part, like humor. Okay, let's send this meme. Take a good look at it, by the way. You know what it means. I hope you understand. Look, she can read the mirrored text, knows the expression POV, and realizes that this text is as if the duck on the other side of the screen sees it, which means it makes the object of the meme the reader herself. Imagine what kind of world picture one has to develop to realize this. But can language models do something really useful? Something really applicable right now that makes our lives easier? Yes, they completely erased the language barrier on the internet. A few years ago, we didn't have such technology. When you don't care what language you listen to a lecture about quantum entanglement in, even if it's in Chinese. We throw it into the browser and it voices it, even by roles. And if you don't have time to listen, the language model will do a short retelling and get the point across. This is called summarization. So for 1 hour, you can learn the content of not just one video, but 20, squeezing out the main meaning from them. It turns out that the consumption of information increases 20 times. Where can this be useful? First of all, in education. Language models will change it just as the internet changed it. Let's start with childhood. A child asks 300 questions a day. Who will answer them? You? No, you'll get tired, and the language model won't. But we'll go further. What's the difference between kindergarten and university? For language models, nothing. You don't learn well there and there because you're either bored or you find it extremely hard. And for learning to be fun, you have to stay right in the middle. Previously, we could not afford it because students are gathered in a group of 30 people and 5 of them will postpone the task for tomorrow, 10 have already done it long ago, and 15 sit and try to understand what they want from them. That is, everyone has a different level of knowledge, but the task is the same for everyone. The teacher's phrase, "I am one and there are many of you," is exactly about this. A personal AI teacher would give the excellent students a more difficult task, and those who don't understand would explain it with a simple example. Already now in practice, a neural network can tell those who have difficulties wherein his code has closed an error. And for someone who already knows everything, it can summarize the lessons, leaving the main thing so that he doesn't waste his time unnecessarily. Yes, now it seems to us that language models live there in a chat window and do not influence the physical world in any way. But what if we show them the inputs to this physical world and put them into real objects? This robotic arm is not controlled by a human, but by GPT-4. It is given a task, take a banana to a bottle of water, and it understands what bananas and bottles are. This is where she was not taught the number 3, but she understands on her own to put the banana here where the 3 is. She also understands the concept of countries and Taylor Swift. Simply put, this machine has become well-read and can solve problems it hasn't faced before. Recently, there was similar news about another robo-arm. Thanks to the neural network inside, it memorizes objects and how best to handle them. For example, It realizes that these objects need to be gently gripped so they don't slip out. And these are square, so you can grab them faster. A large hand based on the same neural network, but with suction cups, is actually used for sorting parcels in a warehouse. Followed by news about a humanoid robot with a GPT in its head. There, the effect of the uncanny valley is just off the scale. No comments here. See for yourself.
Hey, Figure One, what do you see right now?
I see a red apple on a plate in the center of the table, a drying rack with cups and a plate, and you standing nearby with your hand on the table.
Great, can I have something to eat?
Sure thing.
Language models like GPT Chat are the closest thing to what is called a strong AI. That is, one that can solve not only specific narrow tasks, but will be as smart as a human in many ways at once. Why language models? Because for modern humans, the whole world is text. We tell ourselves stories and so construct all our reality. But for neural networks, the whole world is numbers. And by turning text into numbers, we have given language models access to the entire human culture. Here we come to the most interesting part about artificial intelligence. So the simple task of predicting the next word has evolved to intelligence that can understand memes and control robots. But think about it, humans have also evolved from the simple task of finding food and surviving to literature and philosophy.
Humans, what have you learned?
This is the future. This is the future.
In science, there is such a concept as emergence, when from the sum of something simple, a very complex thing is spontaneously born. So from ice flows, fractal patterns emerge. From a pile of birds, murmuration of a whole flock. From billions of sellers and buyers, the economy of the country, and from simple formulas connected in a neural network, something similar to intelligence. Remember that when creating a neural network, people don't know exactly what they will get at the end. By the same logic, predicting what GPT-5 will be able to do is very difficult. No matter how carefully we set a goal for artificial intelligence, there is always a risk that it will understand it differently. For example, we create an unmanned car, and on the first day of the test, it accelerates to 300 km/h, bypassing all the traffic lights on the sidewalk and hitting pedestrians. That means we have to give it a limit. That's it. Easy. We tell him, stay in your lane, don't speed, slow down, let pedestrians and right-hand traffic pass. Simple again. Okay, but on the next trip he makes an unexpected discovery. If you put the car in reverse, the radar in front will not see people and markings. So you can drive in reverse as you please, and an obstacle on the right becomes an obstacle on the left. Again, he's doing what we literally asked him to do, not what we actually meant. You see, in this way, in some task, his goals may diverge from the goals of humanity. What to do? You can keep your hand on the switch all the time, and if something starts to happen, you can turn it off. The creators of ChatGPT even ironically opened a job for a person who will pull this switch with a salary of $300,000, $500,000 a year. In fact, not being disconnected is one of the main goals of strong AI. Regardless of its goals, after all, you can't answer chats or drive a car when you're turned off. Yes, so far all of this sounds like our problems in the future. But when we accidentally create a strong AI, we won't have the ability to roll back. We play this game without saves, and we only have one shot at it. But what if we don't want to turn off the AI ourselves? What if it makes our lives so convenient that we voluntarily give up our free will? It sounds absurd, but answer the question, who today uses a dictionary, a paper map, or a compass? And what for when Google Maps build the optimal route, taking into account traffic jams, not only now but also in any other hour and day of the week, because they remember better than you where and when there are traffic jams. It's the same in other areas. You watch this video because YouTube recommended it to you. You listen to tracks because my program matched them to your mood. You get into a cab at a particular point because the neural network has found it convenient for you and the driver. And you even meet a partner because a dating service gave it to you. You see, we just let the algorithms guide us because we make up to 35,000 decisions a day, from scratching our arm to analyzing the market to finding new careers. And most of those decisions are the minutiae of routine. So why not trust and delegate them to artificial intelligence? But with each such decision, we leave less and less freedom to ourselves. Why write a text when a GPT chat room will write it better? Why paint anything in the world when there's Midjourney? We'll get used to there being an entity that makes all the decisions better than humans. Yes, humans don't always act logically. Did you know that the fate of defendants depends on how well the judge ate? Yeah, a judge who isn't hungry is more likely to acquit them. So maybe it's better to trust algorithms to make the big decisions. No one can understand them completely, but their decisions will not depend on their mood and stomach contents. I can easily imagine that in 10 years, the AI will suggest to some banker to become a baker, because based on his likes, the neural network sees that he wants to change his profession. And in his daily routine, it sees his habit of getting up early, and in his hobby, the pleasure of working with his hands. At the same time, she knows that a baker is needed in a bakery near the school where the banker's children attend, and judging from his correspondence, he would like to see the children more often. The banker will drop in salary, yes, but no big deal, because he's about to receive a large inheritance, judging by one of his relatives' medical records and an extract from his will. What human brain could analyze all this and give better advice? We won't always understand the logic of artificial intelligence, but we will listen to it. From the tyranny of algorithms, we will move to the tyranny of comfort. So the future has already arrived, and it's time to notice it.
Humans, what have you learned?
This is the future. This is the future. Human error.
Humans, what have you learned?
This is the future. This is the future. Human error. This is the future.